This presentation starts with a brief overview of the Blackbird user interface, followed by examples of the lookback TDOA function being used against different signal types. The Blackbird user interface consists of a number of dockable, floatable, and resizable windows, which means that you can choose whether to display any of the windows, where to put them, and how big to make them. Any particular layout of windows can be saved so that a particular operator or a particular operation can recall a certain configuration of windows. This screenshot shows an example layout of the Blackbird user interface. This particular configuration of windows consists of the mission window, the automation window, the search window, the spectrogram window, the intercepts list window, and finally the map window. A brief description of these windows follows. This is the mission window. It shows the frequency range that the sensor equipment is monitoring. In this case, 440 to 480 MHz. This is the automation window. It shows the automation tasks that have been set up. In the first movie example following, we're going to be showing lookback TDOA working with a short duration signal at 451 MHz, and these icons show that the action calls for marking the transmission with a red tag and requesting a TDOA measurement. This is the search window. The search window allows an operator to filter the results that are displayed on the spectrogram, intercept, and map windows. In this example, the filter is set to show all signals from the current time until 2 minutes ago, and to show the range of frequencies that have been set in the mission window. This is the spectrogram window. The x-axis shows frequency, and the y-axis shows time, with the current time at the bottom of the display. The shaded area here shows the bandwidth selection of the real-time DDC. The Blackbird system automatically detects when a signal appears, and records both the bandwidth of the signal as well as the time that the signal came on and the duration of the signal. This is the intercept window. It shows the same information as the spectrogram window in a tabular form. The columns in this example are tags, availability of recording, the measured signal center frequency, bandwidth, signal power, time and date that the signal turned on, signal duration, the geolocation of the signal, and finally the number of sites reporting a TDOA measurement. Finally, this is the map window. Site 1 is at TCI's location, and sites 2 and 3 are two locations in Silicon Valley, around 20 kilometers from TCI's factory. On this screenshot example, there are several sets of TDOA isochrones. One set produced between sites 2 and 3, one set produced between sites 1 and 3, and one set produced between sites 1 and 2. The calculated geolocation for each set of isochrones is shown on the map. In this movie example, we'll be looking at a modem that is sending 200 to 300 millisecond data bursts every 2 seconds with a bandwidth of around 15 kHz. As the system detects each burst, a lookback TDOA measurement request is sent to each TCI Model 350 system to request IQ data for that frequency and bandwidth and time period. The IQ data are then correlated, and the resulting TDOA isochrones and geolocations are shown in the map, with geolocation results appearing in the intercept list table. Different views of the same data are shown in the windows. Here, the geolocations shown on the map appear as text items in the intercept list screen, while the spectrogram screen shows the spectral presentation of the signal. The 5 most recent signals have been detected and catalogued, and TDOA measurements have been scheduled, and lookback TDOA processing is running in the background to provide TDOA geolocation results to these signals. In the previous example, we were looking at a bursting type signal where the system is able to trigger a request for lookback TDOA on each detection of the signal's appearance. In this next example of a long duration signal, we are showing a commercial FM broadcast, and the system has been set to automatically request a lookback TDOA measurement. The system is continuing to detect and catalog all signals within the system's frequency mission range. Then, on the intercept list screen, we highlighted each of 15-second segments displayed for our signal of interest, which highlighted the same set of data in the map and spectrogram windows, and then showed that the metadata pops up when the cursor is hovered over the detection on the spectrogram window. In this last set of examples, we're looking at a series of aperiodic short-duration narrowband analog voice signals. Each transmission is detected and catalogued, and lookback TDOA measurements are automatically scheduled on each detected signal of interest.
10-4, about 2.
10-4 in 2 minutes, 76 over 9.
09, the same.
10-4, 7 Bravo 10, copy.
3, I copy for both of them.
10-4, thanks. And 71 Bravo 3, looks like systems needed over at the coroner's office. Apparently there's a couple of dogs, a pit bull, and then a mixed breed that's...
We paused the scrolling of the spectrogram window while we highlighted a few signal detections in the inset list window, but note that the system continued to detect, catalog, and perform lookback TDOA measurements in the background while the spectrogram window was paused. No signal data was lost. In this last example, we show use of the map to display both TDOA isochrones and fixed results for the same type of short-duration narrowband analog voice signal.
What time I confirm was that 921 or 929? Last year is 921. So anyone, Tom, know with your second?